All right, so the first object we need to make is this vertex declaration. And this isn't really rocket science either. Like all of these are simply go to your device, call create, vertex declaration, and that's the function you need to fill out to make this vertex declaration. Take some parameter here, and then it's going to return as an out parameter the vertex declaration. And then when we're done with it, we'll go ahead and dispose it, because these are all COM objects, just like everything else. Okay, so let's go look up how to properly make a vertex declaration. Or a vertex declaration looks like it's created with an array of vertex elements. And a vertex element is a descriptor of what's in our vertex. So we have to decide right now how we want to organize our vertices. And so one way we could do this, we just write what would we want in a vertex. Well, this we're going to want a position, and we're going to want a color. And then the question is, how do we want to represent that position? Well, these are 2D rectangles, so we need 2 dimensions at least. So let's go ahead but rectangles kind of overlap, so maybe we need 3. And things like to process in 4s due to MMX style instructions. So screw it. I'll just make it a 4 vector, just because that's a reasonable place to start. If we need less, we can always come back and chop it up and make it smaller. But for now, we'll make it a 4-length vector. We got to define that. A vector with 4 floats in it. And then color, same thing. You can choose between ints, you can choose 16-bit, you can choose whatever. Again, not really being stingy at the moment. We'll go with a 4 float color. And so here is our vertex format that we're going to start out with. And yeah, I might call this the fill2D format, but since you end up having a bunch of these and you don't tend to want to make too many declarations, I'm just going to call it vertex vec for color. Like, it's kind of stupid, but that's how these things tend to get named, describing exactly what's in them. So that's our vertex format that we're going to use. And now we have to describe it using these vertex element structures to the video card. And the way we do that is we just go ahead and make an array. And we put elements in until, unfortunately there's this till who knows where, and this end macro knows where. That's the end. We got to put that at the end. But otherwise, we just fill in fields with the values in the struct that represent what we're talking about, what our vertex declaration looks like. The first one is the stream. Turns out you can split vertices across different streams. So like maybe the position is in one stream and the color is in another stream. And you might do that. Different render techniques sometimes can take advantage of it. We're not doing anything complicated quite yet, so everything's going to be in the first stream. Second parameter is the offset of this particular field relevant to the start of the vertex, and 0. It's the first one. Next is the type, and we chose float4 for our position type. Next is the tessellation method, and this is a little bit of complication for when you're using more complicated primitives other than triangles, which nobody really does, but if you were, the card would need to know how to tessellate them property. Next is it's often called the semantic, or something like that, the usage. It describes what this field means, and the card can then use it. Like, for example, at the end of the day, you need to output a position and a color. Like those are the like which pixel is where, what color. And so position, you're saying that this field represents the position of the vertex. And then finally, if you had in some rendering techniques, you have multiple positions or colors or whatever. Most common is texture coordinate. You have multiple texture coordinates. You could just, this is the 0th texture coordinate. This is the first one. This is the second one, etc. So that's our first field. Our second field is offset from the first 16 bytes away. It's also a float 4, but this time it is color, is what's in the second field. And that's it. And then we take this, send it into the vertex declaration, release, and in theory we should create a valid vertex declaration. Let's go ahead and comment some of these things out. We can actually fill this one in. pdevice or fill2d pdecal. Comment the rest of these out while we're in the middle of filling them in. Compile and run. And at our breakpoint, we got to the init. We set up this array, and now we're going to call create vertex declaration, and we step, and yay, we successfully created a vertex declaration. In theory, we're going to come in here, and we're going to set that vertex declaration. We should go ahead and set up our terrible error handling, but to make sure this vertex declaration is valid at this point, and we set it, and everything's okay. So we're still not drawing anything different, but we have set one piece of state on the video card, the vertex declaration. Next video, we'll go ahead and set up the vertex buffer and hopefully the index buffer too, and go check it out.